Hello, chaps and chapettes. Now, we've had a question from one of my students asking about what happens if you start adding resistors together. And for series resistors, it's quite easy. For parallel ones, it's a little bit difficult. So I'm going to show you this now on my whiteboard, and we'll see how it goes. So here we have resistors in series and resistors in parallel. So we have let's find a different color pen. Resistors in series and resistors in parallel. Nice and easy. So what we have to think about with this one is how is the resistance going to change if we stick them together in a line like this? And you have to think about this. What is going to happen to the resistance if you make your material longer, as in the electrons have to travel further through the material? Well, that's kind of easy. It means that the resistance is going to go up. There's got more stuff to go through. So, with that in mind, the formula becomes quite easy. R total is equal to R1, so that one there, plus R2, and so on and so forth. You can just keep daisy chaining your resistance together, and it's just the sum of all the resistors. However, when we have resistors in parallel, this is when things get a bit more interesting. Because now, we're not just making the chain longer. Just realized my circuit's not going to work. Hang on. There. Can lose marks quite easily for that. So what's happening here? We put our resistors in parallel. What does that mean for the actual total resistance itself? Well, unlike before, where we're making our material longer, we're now making our material wider. So what we have is a larger surface area. A larger cross-sectional area. And if you've got a larger cross-sectional area, there's actually more charge carriers per sort of slice of your material, which means that the resistance is going to go down. And that makes things complicated. So what this means is we need a formula which is actually going to lower the resistance of our resistors in parallel. And it looks something like this. This is a real brute force method one, but it will work for no matter how many resistors you have, and it's very similar to this one, so it's nice and easy to remember. 1 divided by R total is equal to 1 over R1 plus 1 over R2, and so on and so on. You can just keep stacking on any resistors you have in parallel. So you'd have another one down here, R3, then that just becomes plus 1 over R3, and you keep going on down. And what this means is that you will end up with a smaller resistance than what you started with. So if you had like 10 ohms here and 10 ohms here, you'd end up with the total resistance of being less than 10 ohms. And there you go.